All right, master plan part 3.
What's up, guys? Welcome back to another video. Today I'm going to be going over Investor Day and Master Plan Part 3. I saw a lot of hate online. Tesla has even gone down about $20, $30 since Investor Day and Master Plan was announced. I thought it was one of the best days in Tesla history. They're putting out a 25-year plan to be one of the main leaders of transitioning the world to sustainable energy. And people were saying it's a dud, that they messed up. They've been working on this for a long time. I saw so much hate for it. I think a lot of people that were discouraged are maybe more of day traders, and they were wanting some just like big announcement that was going to shoot the stock price up. But really it was just in my opinion, a 25-year plan of Tesla's future to become by far the biggest company in the world. They even hinted at getting into planes and boats, HVAC systems. They covered 2 different cars that looked potentially like a van and then a smaller size car. So to me, they gave so much information and it was so densely packed that I'm gonna break it down into a few different videos going over just in little sections of like 30 minutes, 30 to an hour per investor day, and then making those into little summaries because I think there was just so much info that people got lost. A lot of people, I personally wanted them to announce the new car or show the next generation vehicle. They didn't do that. They did announce that they are confirmed to build a new factory in Mexico, in Monterrey, which is very exciting, which they will be making that, which gets me excited. I live in Mexico right now, and when I moved here, there was an apartment building that was just starting to get built. I thought it was gonna take a year. In 3 months, the thing was done. Obviously, the foundation was already built. It's not like they built a whole apartment building in 3 months, but how fast this building went up and is just like a nice like apartment building now is honestly just unbelievable. I would have never thought it was possible, but in Mexico, they work fast. And they're talking about making this one almost twice as big as Giga Texas, which I think is maybe right now the biggest factory in the world in terms of footprint. So if they're trying to make it double that or even just the same size with the next generation car, it's such an exciting time for Tesla, and it's selling at prices that it was a couple years ago. I think it's one of the greatest times. But let's get into Master Plan Part 3 and Investor Day and see some of the highlights that we can go over.
The thing that I think is we wanted to convey, probably more importantly than anything else that we talk about here, is that there is a clear path to a sustainable energy Earth. It's not, it doesn't require destroying natural habitats. It doesn't require us to be austere and stop using electricity and sort of be in the cold or anything. The story, and I think this holds together quite well, and we'll be actually publishing a detailed white paper with all of our assumptions and calculations, is that there is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans could actually be supported sustainably on Earth. And I'm just often shocked and surprised by how few people realize this. Most of the smart people I know actually don't see this clear path. They think that there's not a path to a sustainable energy future, or at least there's not one that is sustainable at our current population, or that would have to resort to extreme measures. None of this is true. So we're going to walk through the calculations for how to create a sustainable energy civilization.
Okay, a couple points from that clip. I love that he says that they can support with their future that they're looking forward to creating, a fully sustainable future, that it's with abundance. It's not that I was in Europe over winter and the heat could only turn on for certain hours of the day. And to have a sustainable future that looks like that is not very exciting. And I think a lot of people might think that if we're going to go towards electric, or it's like, who wants to live in a time when in developed countries, you have to only have power on for a certain amount of time, and it's just unbelievable that we have to deal with stuff like that. So the future is very bright, and also how he talks about how there's people that think that we have too big of a population, our population growth needs to slow down because they're going to take resources. It's usually coming from people that use way more resources, such as private planes and different stuff like that, than the average person. So it's just completely hypocritical. Instead of looking at the problem as like an engineer like Elon, where he's saying, let's just figure out a way that we can have more energy than we could possibly need, instead of saying, oh, we need to cut back on our energy use and we need to control population growth. Instead of looking at it like that, you could say, let's just figure out a way to produce way more energy than we possibly need so we can live in this abundance.
And to set the stage, today our energy economy, let's be honest, it's dirty and it's wasteful. Over 80% of global energy, primary energy, comes from fossil fuels, and only 1/3 of that global energy actually ends up delivering useful work or heat. This is the problem statement, but we're here to talk about the solution.
Yeah, it's like some of this I'm going to elaborate because there's a very wide range of technical expertise out there, from people who are like, whatever, level 9 wizards in the subject, to people who do not do engineering at all. So if you have a gasoline car, you're converting less than 1/3, often maybe only 25% of the energy in the gasoline is converted into motion. The rest is turned into waste heat. That doesn't do any good at all. And there's a lot of energy required even to get the oil out of the ground, to refine the oil, and to transport the gasoline to the gas station. So when you look at all that, for a typical gasoline car is actually going to be using less than 20%, fully considered, of the energy from the oil actually goes into motion. So this is when we see people doing calculations for what does it take to create a sustainable energy Earth, they assume that the same energy amount is required for an electrified civilization versus a combustion civilization. This is not true, because most of the energy of combustion is waste heat.
And even to get the fuel to combust in the first place and get it to the end use, there's a lot lost along the way. I mean, this is the primary energy consumption, 165 petawatt hours a year. Petawatt hour is a trillion kilowatt hours, so it's a large amount of energy. But the nice thing about electrified economy, there's a better way, we're going to talk about it, is that through end use efficiency and through efficiency along every step of the way, actually the total energy use halves. So this is one of the most enabling aspects of electrifying everything, is that the sustainable energy economy is that much easier to accomplish. It's actually half the problem statement of the fossil fuel economy.
Yeah, and we're being conservative here, so it could be better than half, but we're trying to have assumptions that are reasonable, not overly optimistic, in fact slightly pessimistic. So it's really better than half, but just say it's easy to make the argument that we need half as much energy with an electric economy versus a combustion economy.
That statement right there is just absolutely mind-blowing. You need half the energy with the sustainable energy future than you do today with renewable electricity. It's just unbelievable. Another thing is, like they said, it's just a lot dirtier. It's way more efficient. And one of the main reasons I left LA was I was driving back from a Joshua Tree, which is a few hours outside of LA. It's a national park in California. And as I'm driving back, I thought it was cloudy over LA, and I thought it was maybe potentially raining. I could see it from a distance. And then when I drove into LA, all of a sudden I realized I'm in it, and it doesn't even seem like it's raining or it's even that foggy or anything like that. It's just when you're in it, you can't even tell it was smog. The smog over LA and different big cities around the world is just absolutely disgusting. And it's insane that people have to live in these conditions. And when you're inside of it, you can't even really tell unless you go outside of some clean area and then you look back and you drive into it. You're living in poison, and it's insane that people have to live with this around the world. So this transition is just, to me, completely mandatory, and just a way cleaner future for and uses way less electricity. it's just a no-brainer, and it's just so exciting that there is a company out there trying to change the world instead of just staying stagnant in our ways.
So how the master plan works, you want to talk
Yeah.
about?
So the thing that is needed at very large scale that is not currently present is a vast amount of battery energy storage. Our rough calculations are that this is about 240 terawatt hours, or 240,000 gigawatt hours. This is a lot of batteries, but it is actually a very achievable amount. We'll go into details on that.
Yep.
So that's a combination of electric vehicles and stationary storage. So if you've got solar or wind, you've got to store the energy when the wind is not blowing, the sun is not shining. And so we're assuming sort of an 8-to-1 ratio of stored energy to power. So 30 terawatt hours of power, 30 terawatts of power. Our actual capital expenditure calculation for manufacturing investment is more like 6 trillion, but we made it higher to make it 10 trillion.
And this is across mining, refining, battery factories, recycling, vehicle factories, all the things that we're going to talk about needing to invest in to build the sustainable energy economy.
Yeah. Now, if you look at the total world economy, it's just under 100 trillion. So if this was spread out, say, over 10 years, it would be 1% of the global economy. Over 20 years, it would be 0.5%
Very
of the
doable.
global economy. So this is, not a big number relative to the global economy. As Drew mentioned, you need about half as much energy with an electric economy versus a combustion economy. And in terms of wind and solar, how much land would be used? It's less than 0.2% of the land area of Earth. Generally, people don't realize quite how much energy is reaching us from the sun. It's roughly a gigawatt per square kilometer. And the sun doesn't shine all the time, but it's if you multiply that by, say, 4 to get the continuous power, 4 or 5, then that gives you the land area of solar. And you can put wind and solar often in the same place. So a lot of places that currently have wind, you could have solar there, and you double your energy.
You can also put wind offshore. It doesn't even need to
Yeah.
be on land, so wind is even more flexible.
You could put solar offshore too.
Yep.
So Earth is 70% water. Anyway, the point is that with a really a remarkably small amount of Earth's land area, we can go fully sustainable. Yeah.
And do the resources and raw materials exist to support this transition? We'll go through that in detail, but we do not see any insurmountable resource challenges at all. In fact, in the end, we should be mining less ore to accomplish this economy than we currently do with the fossil fuel economy, and we're going to talk through that.
Yeah, just to emphasize that again, the electrified economy will require less mining than the current economy does.
Yes.
Less, not more.
Even everything right there is pretty mind-blowing. 240 terawatt hours of storage, 30 terawatt hours of renewable power, 10 trillion investment. And like they said, that's in 20 years, 500 billion per year. In 20 years, you have a fully sustainable energy future for the entire planet. This isn't just the United States, it's the entire world. It's like we have a big incentive to do this and do this now. I don't know, Tesla should be working with governments around the world to try and transition this as fast as possible. Like you said, he thinks it's closer to 6 trillion, but they're trying to be conservative and saying 10 trillion. So really at that 500 billion per year could be close, a little over 10 years to transition the whole planet. I don't see how this isn't like a massive priority from all countries around the world working together to help this plan. And it takes half the energy. And I saw something cool recently, was a solar farm in China where it was like on the mountain on like both sides. I'll post a little video to that right here. And 10% of the world GDP. It's just very exciting that they're working on this. And with the collection of help from other companies, like they said, from mining to, transporting the resources, refining, battery making, deploying solar, deploying battery storage and wind. There's so many things that have to do with this. There's so many amazing business opportunities that I think the entire planet should be working together to help get this goal and transition the world as fast as possible to renewable energy.
First, renewably power the existing grid. Second, switch to electric vehicles. Third, switch homes, businesses, and industry heating to heat pumps. Fourth, high temp heat delivery and storage for high temp industrial and chemical processes, and a little bit of green hydrogen in there for chemical processes that need hydrogen. And finally, sustainably fuel planes and boats. These are the 5 areas, and we're going to go into detail on all of them.
Yeah, I mean, my personal opinion is that as we improve the energy density of batteries, you'll see all transportation go fully electric, with the exception of rockets. That's awkward. But you can make the fuel with CO2 and water. So you can make methane with CO2 and water. So
And
in
you
fact,
can do that with just electricity. So.
Yes, exactly. So, in fact, on Mars, if we hopefully get there at some point, the atmosphere is CO2, and there's water ice throughout Mars. So you can take the CO2 and H2O and turn that into CH4, which is methane, and oxygen. So ultimately, even rockets can be electrified.
So you see that right there? When you see the 5 pillars that they say to transition the world off fossil fuels, some people just think it's just a presentation of what you need to do. This is what they're going to be doing, in my opinion. They're going to be working on renewable power from solar and wind and storing that in stationary mega packs. So, you get your deploy solar panels in mass solar farms and then store the excess energy in battery packs. Next, switch to electric vehicles. They've been working on that as well. Switch to heat pumps. So I do think that they are going to work on HVAC systems. I think that everything on this chart that they will be working on and doing is part of the Master Plan 1, transition the world to sustainable energy. So I don't think they're just going to be working on electric vehicles and the solar. I think they're going to use all of these. High temp heat delivery and hydrogen. We'll get into that in a second. And then to me, the most exciting part is sustainable fuel for plane and boats. And as he just said, as the energy density in the batteries gets better, all transportation will turn to electric. So can you imagine eventually Tesla starts working on the producing batteries for the boats and planes? And he said that it already could work for short haul flights for planes, but eventually long haul flights. It's just, no company has this potential future. No company is looking at the future and trying to see every little thing that they can do. A lot of people still think that Tesla is just a car company. I don't know how to help you with that, but it's just unbelievable the amount of areas that they're gonna go into and how much this company still has to expand. Like I just said, people still think it's a car company. They have solar. The megapack business potentially is going to be, from just even this, could be double the size of the electric vehicles. And they get into planes and boats and HVAC systems. Man, the future is bright.
Trillions of investment at the bottom of the page. This is already actively occurring in front of us. 60% of the generation added to the US grid was solar in 2022. And actually, on a year-on-year basis, solar deployment is growing 50% year-on-year as of 2022. So this is a serious upswing, and if we continue this trend, this is going to be behind us before we even know it.
Yeah.
Second, switching to electric vehicles. Again, 21% reduction in fossil fuel use by doing this alone. Obviously, Tesla is heavily engaged in this activity, along with many others. Overall, EV production grew 59% year-on-year in 2022, and EVs hit an amazing 10% market share. I mean, it's an awesome milestone. I'm super excited to see that. I gotta.
Yeah, I mean, this is obviously happening very rapidly, and I mean, I think really all cars will go to fully electric and autonomous, and so riding a non-autonomous gasoline car is going to be analogous to riding a horse and using a flip phone. That's basically going to be the situation.
And we actually took a somewhat conservative assumption here in terms of how many batteries are required, because the more the fleet is autonomous, the smaller the fleet needs to be just from a utility basis. So we're not accounting for all of those benefits, or really much of those benefits at all in this number. And what does this fleet look like? Just rough view from our perspective. Of course, we could be wrong, but you can see the sort of breakdown of the fleet by millions of vehicles. Our goal is to do 20 million electric vehicles a year.
Yeah.
Some two cool things in there. You saw that to transition the grid to sustainable energy cost about 800 billion, which to me seems very doable. I don't know how countries aren't just trying to switch as fast as possible to that. That'll change the world. But looking at the switch to electric vehicles looks like the biggest investment, as I say, $7 trillion. Obviously, their goal is to make 20 million cars per year. So it's going to take a long time. They're not going to be the only ones making cars. They're not going to be the only ones transitioning the grid. I just see them as a percentage of making this transition. Other companies, of course, are going to be in the mix. But what's cool is they have the cover on one of the biggest ones, which I think is just a small compact car that's cheap, that can be sold worldwide. Under $25,000 would be reasonable to have sales all around the world. And then the 300 million is, to me, the only car type that's not in there is a bus/van. So I think that's 100% what they're going to reveal, is some sort of robo-taxi van or bus. Again, I'm speculating now, you can't see it, but to me it looks like a van, which is super exciting. Even if it was like some sort of like Sprinter van that you could live out of, I can see tons of people opting to get something like that. There's already, van life has gotten huge since COVID. I could see an electric van just absolutely doing amazing. And then the small compact car will be by far the best-selling car in the world. Volkswagen just even mentioned that they want to start putting out a under $25,000 car. So happens to look very similar to a Tesla on the inside. And I think they're just trying to, copy Tesla. But again, I hope people hold them just as accountable for missed deadlines, because they say they want it to start being produced by 2025. And people always get on Tesla for, stating things and it coming out a little bit later. Let's see if people have the same accountability for Volkswagen or even GM that says they're going to have 30 different models by 2025. We'll see if any of that happens. Also, when they talk about you're going to need a lot less cars, when there's autonomy, of course you're going to need a lot less cars. I really stuck into my mind when I read Physics of the Future by Michio Kaku. He talks about how autonomy, how many hours per day, if you have a car, is it parked? Most likely it's parked around 20 to 20 plus hours a day. So you have a car parked for 20 hours a day and you're spending, anywhere from, a few $100 to over $1,000 a month on a car that is parked for almost the entire day. And everyone has their cars parked for that amount of time unless they're driving for some special occasion or they're a truck driver. So the efficiency for car use is just absolutely unbelievable. So when autonomy comes and you could use ride sharing, the amount of cars in use are going to be way less. Even how many people work from 9 to 5 and are parked from 9 to noon, maybe they go out for lunch, and then they all drive from maybe 5 to 7 or 5 to 8. It's just the least efficient system ever. Cars are all driven around the same time, it causes traffic, and then they're all parked for similar times. So the fleet size will go down by what they just talked about, close to half when autonomy comes. And like I've said before, this investor meeting and master plan is a long-term future look. This isn't for next year. This is for the 2030s, the 2040s, the 2050s. And so if you're an investor that's looking super, super short term, it might not be the stock, but if you're looking at a company that can help you retire and be a potential dividend stock in the future and be one of the largest energy companies in the world, this is the company. They're basically giving you a plan of how they're going to grow for the next 20 to 30 years.
Enabling is this end-use efficiency point. Tesla Model 3, it's 4 times more efficient from the well to wheel than a Toyota Corolla. And that's all about the efficiency of getting the electricity into the car in a sustainable energy economy, and then how efficient the car is in transferring that stored energy to motion on the road. When compared to the engine in the Toyota Corolla and all the extraction, refining, transmission, distribution of the gasoline to the Toyota Corolla. And just for, this is a fun reference, Model 3 can drive over a mile on the energy it takes to boil a pot of water for pasta, and then it can drive another mile on the energy it took to cook the pasta. And that pasta is 1 pound, and Model 3 is like 4,000 pounds. Just to give you a sense of just like, it really doesn't use a lot of energy to move a Model 3, that 4,000 pound object, down the road.
Yeah, also, heat is a lot more energy than motion.
Yeah. Yeah. But people, you just boil a pot of water, you don't even think about it. It's just interesting how efficient these cars are. Next, switching to heat pumps in homes, businesses, and industry. Right now, heat pumps meet 10% of building heating needs. Install rates growing 10% year on year. It really needs to accelerate. Heat pumps can serve, heat applications up to 200 C in businesses and industry. And from an investment perspective, as you can see on this page, this is actually the lowest hanging fruit in terms of displacing fossil fuels. You might be saying, well, what exactly is a heat pump? So heat pumps don't move heat, don't create heat, they move heat. When you think about like the natural gas furnace in your house, it is generating heat itself, but what the heat pump is doing is actually moving heat from outside of your house into your house. They're just an air conditioner or a refrigerator in reverse. So we're surrounded by heat pumps. There's they're all over this factory. They're in your house. And all this really is about bringing them to displace all the fossil fuel heating in all of the homes, business, and in the industry that we can. And from an end-use efficiency perspective, there's a three times reduction in the total energy required to heat these buildings. So a real obvious thing to do.
Yeah, heat pumps. They're in our cars, now as default. And at some point, we might make a heat pump for our home. So
that right there is very exciting too. To me, that seemed pretty obvious that they're for sure. If they already make heat pumps for the Teslas right now, why wouldn't they get into heat pumps for homes and just get into HVAC systems? It's just a super exciting little subcategory that they can get into, from solar roofs to battery storage, electric vehicles, and now HVAC systems. Yeah, and then as we're going to get into planes and boats.
Yeah.
And lastly, a small part of the pie, but a necessary part of the pie, is sustainably fueling planes and boats. Shipping accounts for 3% of global CO2. It's ripe for electrification. Even with lithium iron phosphate, long-haul ships can be fully battery-powered. So that's a great opportunity to electrify. Energy density is a little bit harder for planes, but short-haul is doable today. With some improvements, we'll get long-haul underway. But even in the meantime, we can leverage sustainable aviation fuels produced and stored using excess renewable electricity. There's a lot of work going on in this space. And it's not, yeah.
Yeah, I mean, to really get long-range aircraft and long-range shipping to use lithium-ion, you need to redesign the ship and not just...
or the plane.
And the plane. To take advantage of the fact that it is a new source of energy. It's a different architecture. So just like with an electric car, you wouldn't just take a gasoline car and stick a battery in it. That's very, very suboptimal. It's much more efficient to have the battery be the structure of the car, and make it mass efficient and optimized for batteries. The same if that's done with aircraft, I think you can get long-range aircraft at around with cells at around 450 watt-hours per kilogram, which you can buy it right now. Actually, it's expensive, but I think that price will come down.
So when we stack up all of these efforts, we end up with the numbers we shared at the beginning of the presentation: 30 terawatts, 240 terawatt hours, $10 trillion. And you may be saying, like, I need some context. Is this feasible? Spoiler alert.
It's super, super cool if Tesla could get into boats and planes, like they just said, that it's already possible right now. I don't think that's their main focus right now, but I mean, even to ship their cars around the world and using boats, it's one of the most, it's tons of emissions from long haul boats. But if they can electrify that to ship even their own products around the world, to me, that seems like a no-brainer. And then the planes, I don't see that happening until way past 2030. But again, super exciting future that eventually these planes will be electric, boats will be electric, and Tesla could be leading the way to help transition this. This to me is one of the coolest parts of the presentation so far, is that I didn't even think of Tesla potentially even getting into boats and planes, but like they just said, it's even possible for long haul planes right now, just extremely expensive. So as the energy density for planes gets better, it'll be entirely possible. Also changing the structure of it. For instance, like right now in the wings of a plane, that's where it holds the gas, the oil to fuel the plane. So it's kind of similar to the battery structure for the Tesla. The floor of a Tesla is the battery. So you'd have to kind of change, maybe the wings would be the where it stores the electric panel, or it's the bottom of the plane. Who knows how they would do it. Yeah, I guess it could technically be the floor of the plane, and same with a boat. Could be very similar to that. So it's exciting to see how they will transition, because you don't just put these batteries onto a plane or on a boat. It doesn't work that way. They tried that with the initial Roadster when they took out the engines for the Lotus Elise, and then they try to put a battery system into there. It's not, you have to make the thing from the beginning and make it a lot more, it's just not, like you said, it's not reasonable. It's better how they've turned the battery pack into part of the car, to be the floor of the car, and they attach the seats on top of it. We'll see. I mean, this was only like 20 minutes into the master plan part 3, and the total presentation was like 4 hours. You can see how energy dense it is. They've already talked about getting into HVAC systems and air conditioning, from solar and wind farms, to even potentially making planes and boats. So I don't know how anyone could possibly say that Master Plan Part 3 was a dud or Investor Day was a dud. I don't know what they were looking for, but to me this is 20 minutes in, and it's just so energy dense that maybe it was just too much, and it was kind of, I guess, maybe boring for some people. I don't know, but to me, Tesla is by far the most exciting future. I mean, if you look at like Apple, what does Apple produce that's new? They talked about an Apple car. I think they've already given up on that. No company has the potential future of Tesla, and I'm so glad that Elon's around. He's changing the world by far. No one's even close to what he's doing. It's amazing the hate he gets. Yeah, that's all I have for today. I thought I would get more into the presentation, but it's just so energy dense. I might make this into maybe even up to 10 videos, just breaking down every single section of Investor Day, because there's just so much into it. But I'm back. I took a 2-week break off. I got engaged, had some stuff going on in my life, but I'm back. I'm gonna try making these videos daily or every other day. Tesla to me is one of the most exciting things in the world. I'm doing this anyways. I'm doing this to people I know, to friends and family. I'm talking to Tesla about this, so it's like, why not make this into my channel and just go over the research that I'm going over anyways with you guys. So thank you guys for everyone that follows me. I've had some friends say they want more videos, so I'm gonna make more videos for you guys. I wanna make this honestly just even a job that I do, and just put out daily Tesla videos informing you guys. So help me out if you guys want. You can like and subscribe to my channel, and I'll see you guys tomorrow with another Investor Day video. Thank you.